Almost after. Welcome, everybody. Thank you for joining us. Happy Thursday, September 21st. I am Karen Bash with VMware. I'm here with our esteemed Tanzu partner, Capstone IT. Thank you for joining for this webinar series focusing on how to deploy and manage your modern application portfolio, specializing in containerized applications. I will pass it over to Paul and the rest of the Capstone team. As a couple reminders, this webinar will be recorded so you will be able to watch it later. And as well, we will be answering questions during the session, and we will likely have some time after the session to go through the Q&A. Please use the Q&A function of the webinar, as those are saved for later reference and we can get back to you. The chat, we don't get a report afterwards, but Q&A, we do get a report. So please put all your questions in the Q&A panel. Thank you, and I'll hand it over to Paul.
Karen, thank you. Paul Peterson with Capstone IT. Great to be with all of you. Appreciate your time today. And we really have put together, I think, a pretty good solution, a pretty good presentation here for you, and we look forward to sharing it with you. I'm going to be your MC today. I'm going to just briefly go over our agenda, the speakers, et cetera, because we want to get into the meat of our presentation. Let me go down the list of presenters if I can. So our very first presenter is from VMware, Kirti Apte. She's with the Modern Applications Platform, and she's a systems engineer, all things Tanzu, all things containerized applications, and the platform that VMware has for exactly this. So Kirti, thank you for joining us from VMware today. Glenn Tyndall is our VP of Solutions at Capstone IT. Glenn actually had the vision for our platform, and so we're thrilled to have him on today. He's going to go through a little bit more about the architecture of our CAS platform and what makes it transformational. I'll talk a little bit more about exactly what CAS is on the next slide. Thank you, Glenn. And then Ken Ryder is a senior solutions architect with Capstone. Great to have him on my team. He's the smart guy in the room. So he will talk a little bit more about how we create tenants within CAS, and then we can wrap a CI/CD pipeline around that for modernizing applications. My sense is we're probably going to have some time here at the end. We can certainly take some questions. We want to be available to you. I know that just from experience, it will take some iteration to go through any specific questions you might have. The very last slide, I've got some contact info where you can reach out to us and we can engage with you in a one-on-one conversation. We'd love to do that, but we're prepared to at least at a high level address anything you've got today. So again, on behalf of VMware and Capstone IT, thank you guys so much for joining us today. Capstone IT, who are we? We're an Omaha-based Midwest integrator partner. Specifically, we're a cloud-native VMware Master Services competency partner. We're real proud of the work that we've done with and on behalf of VMware as well. You've heard me mention the acronym more than once, and I want to make sure I give it a definition. We have created a purpose-built container as a service offering, and it is built on VMware Tanzu. It's essentially VMC on AWS, hence the acronym that we've created, Container as a Service. We follow that with a plus sign. Just the nomenclature there. The plus sign was indicative of some of the value-add services that Capstone IT can help you as a prospect or a customer with as it relates to having the knowledge around containerizing applications, modernizing applications, and that's actually where all of this started as a company. We've been around for about 25 years, focusing on IT solutions, and IT solutions, at least for Capstone, includes all the things we're going to talk about today. We also have a staffing arm as well, and so we really have the ability to deliver all things solutions. Specifically for what we're talking about today, we have about an 8-year history of containerizing apps, with customers. That puts us back from a timeline perspective into the days of Docker. So we really have kind of grown up in this space. We're pretty good at it. We think we are, and love to have an opportunity to talk to you about that. Since those days, we now have really focused 100% of our efforts on VMware only, and specifically how that can then integrate into the native platforms with AWS accordingly. And with that, again, I'm really proud of the smart guys in the room. We have demonstrated, engineering folks, and we really focus on a broader focus about being a servant partner for our customers and our vendors. And so we again, thank you. We want to help you on your application journey. Again, we'll go forward and give you some specific context around that. With that, again, as I mentioned, Kirti is going to, I think, lay some foundation as it relates to Tanzu, and then we'll transition on to Glenn and Ken. So Kirti, I will hand it to you.
Great. Thank you, Paul. So before we delve into Capstone Container as a Service, like Paul pointed out, let's try to understand what we hear from enterprises who are embarking on the cloud and containerization journey. So typical personas that you deal with are operators, platform engineers is an emerging discipline, developers, security architects, SREs. With the advent of AI ML-based applications, it is data engineers as well as data scientists. These are emerging personas as well. So when you think about operators, what do operators worry about? They worry about frictionless handoff, alignment between various teams such as developers, security, operations, etc., bringing in standardization and consistency across various tooling, pipelines, multiple clouds. Developers, on the other hand, they worry about productivity. They worry about writing code faster with best practices and release it faster. But having spent 20 years in the software industry, the question that is on top of the mind is, how are our developers spending time? Are they spending time writing code and adding business value? Or are they spending time mastering operational construct of cloud native applications? And many a times what we find is they are left to find the right tools, set them up, manage them, work across different teams, and connect their applications with different applications. And that end up in writing walls of YAMLs for different configurations, as well as maintaining and managing different environment configurations. Security and the CISO, on the other hand, they worry about embedding security and compliance best practices, bringing in guardrails, still keeping developers' productivity in mind, as well as developer innovation and organization innovation in mind as well. Next slide, Paul. But when you think about all these personas, right, at the very core of it is the application-aware strategy. These applications are getting packaged as microservices-based applications. A surge in cloud-native application as well as AI/ML-based applications is expected in the coming years as well. And if you think about CIOs worry about application modernization and migration, and that is their top priority. They focus on business agility. But how do you bring in this business agility? That's the question. And that you get with application agility or the software agility. For example, consider ChatGPT fundamentally transforming the industry. The ability to attract and handle such a large user base so quickly highlights the impact of application agility as well as developing, deploying, and scaling rapidly. Look at the chart in the middle, right? So traditional companies, 1 to 4 releases per year versus world-class organizations, 4K to 18K releases per year. So imagine the agility they have, ability to respond, innovate quickly. Netflix is a great example of that. Netflix pioneered DevSecOps as well as CI/CD best practices. And no wonder because of that, the organizations are moving towards Kubernetes for container orchestration, multi-cloud, as well as they don't want to lock in to one cloud. Open source software is gaining adoption as well. So people, tools, and processes are actively functioning in this realm, and they are within this ecosystem as well. If you go to the next slide, Paul. So this is where the industry is leading towards. There is surge of applications, but at the same time, this ecosystem is really becoming complex. Various tools you have to integrate with each other, scale it across multiple data centers, across multiple clouds. That's the demand today. This increases cognitive overload onto our developers as well as operations team. So imagine Kubernetes and multi-cloud don't want to lock in into one cloud. These are the foundations, right? These are the founding principles where cloud native applications are based on. But there are complexities when you are trying to operationalize this as well as making it enterprise grade. So what are some of the challenges we hear in the industry, right? Lack of Kubernetes expertise, proliferation of tools and clouds, as well as multiple teams creating multiple operating models, causing app delivery to slow down. As well as if you think about Kubernetes production grade application or the enterprise ready application, what do you need? You need routing, you need ingress rules, networking, HA, DR, backup, restore, scaling, resiliency. So how do you solve this complexity and tool sprawl? Cloud chaos that comes with a distributed multi-cloud system. How can you streamline your operations? And what do you need to provide your app dev team so they can to enable faster delivery as well as more secure app delivery? And that's where Tanzu as a platform comes into picture. If you go to the next slide, Paul, now let's try to understand Tanzu as a platform. There are two portfolio of products starting on the right-hand side of the flow, where Tanzu for Kubernetes operations. That provides a consistent operational framework as well for managing the security, compliance, and scale of your modern application. And this is cloud agnostic. This can run across any cloud. Tanzu application platform, on the other hand, it's going to give you rich set of developer tooling with pre-paved path to production for building and deploying your software quickly and securely on any compliant Kubernetes. So this is based on the developer persona. So all these DevSecOps, they are going to work together. There is a collaboration, but at the same time, this portfolio is going to keep separation of concerns in mind as well. And to top it off, Capstone Container as a Service further going to simplify your experience by providing a turnkey application modernization solution, which is based on VMware Tanzu to accelerate your app delivery as well. And we are going to have a deep dive into that as well. So if you go to the next slide, let's recap these essential building blocks of Tanzu and what I just covered, the two portfolio of products. So at the very core of it is Kubernetes runtime to manage and upgrade your clusters consistently across any cloud. We anchor this solution across common management plane that is going to provide centralized visibility and control over your platform, and that can run across clouds. So as it can be edge, it can be public cloud, it can be private cloud. Next, you will deploy your applications onto this cluster. So you need to worry about in-cluster, cross-cluster communication, as well as zero trust architecture. And that's where Tanzu Service Mesh comes into picture. Tanzu Observability, on the other hand, ensures you can effectively monitor and troubleshoot issues faster. And this is integrated solution, right? So we are just providing you integrated solution that comes with data protection to protect your data at rest as well as in transit, as well as global load balancing and advanced traffic routing. that allows you for automated service discovery and north-south traffic management as well. Tanzu application platform, we are not forgetting developers. That is another platform that I covered earlier that is part of Tanzu portfolio that allows developers to focus better on defining requirement for applications, as well as enabling shift left model where security needs to be a part of your deployment process as well. That should not be an afterthought. Supports full portability from development to production, as well as it applies standard best practices, industry best practices automatically onto your supply chains, onto your workloads as well. And that is what we call as the continuous path to production. If you go to the next slide, Paul. So when you think about this path to production, the traditional native Kubernetes deployment, what are you looking at? And these are different things that I have listed on the slide. That is what you go through. And many more things that you have to configure to make your application production grade or enterprise grade. And that is roughly about 11 days, right? So how do you streamline this process with Tanzu? So what we are looking at with Tanzu application platform, as well as Capstone IT, the automation that they have built, is we are eliminating all the steps and walls of YAMLs. It is simple one push experience with Tanzu workload create, triggering a right supply chain under the covers, and have your service deployed to production in roughly 2 minutes. What are we getting with this? We are getting speed, consistency, security, and automation. And that's the value prop of the Tanzu platform and Capstone IT, that CAS service that we are going to talk about. If you go to the next slide, Paul. So with that, Tanzu, I just mentioned lots of capabilities are built into this platform. But how do you measure your success, right? So Tanzu offers a comprehensive set of tools and services to help your enterprises achieve various business outcomes. And few of them to mention are bringing in faster application development, increased developer productivity, scalability, resiliency, cost optimization, as well as curated templates with baked-in security best practices, supply chain-based automated builds, which are going to replace human error-prone process, supply chain security. These are all these capabilities we are bringing in the platform. But how do you measure your success? And that's what this slide talks about, where newly emerging standards such as DORA metrics, for example, deployment frequency, mean time to resolution, lead time to changes, that you can use to track your success. As well as SALSA is an emerging standard as well. How secure are your supply chains? So there are tracks such as build provenance, build track, source track, provenance, hardened builds that can help you to map your business outcomes with the metrics and measure your success. So this is, the entire journey of the cloud native the organizations who are embarking on the cloud native journey. And these are the complexities. So we reviewed that, and now I'm going to pass it over to Glenn, who is going to take you further into the architecture of CAS. So Glenn, to you.
Sounds good. Thank you, Kirti. And AJ, just so you know, my video won't start, just as a heads up. What I'd like to do is set a bit of a stage on the back of what Kirti has outlined and share with the group that over the 8 years of our experience in the world of app modernization, containers, Kubernetes, and the like, a couple of challenges that have occurred is the fact that skill sets are a limiting factor. It's very difficult to find the total number of people that are necessary to build the infrastructure that's necessary to drive app modernization strategies. It's a very difficult skill set to find. Secondarily, there's a lot of organizations that are going through a bit of a transformational journey as well. and that transformational journey is really focused on how their organization better collaborates between the development organization and between the infrastructure folks. So we're seeing quite a bit of an evolution that's beginning to occur. Having gone through the journey and that process of education and understanding with teams, we came to a realization that time to value above all is going to be critical for the long-term success of an organization. And our ability to put a platform in place, as we've discussed around containers as a service, and provide to the customer a faster time to value is really the ultimate goal behind this investment that we've made. What you see in front of you here is an example of a GitOps screenshot that defines the workflows of progression that we go through step by step. The end result being the creation of a tenant in our environment. If you note, as one would expect, each of those steps builds new components or adds new components into the equation here. All the way over on the right, we actually have the ability to ultimately deploy applications as a part of the overall process. This workflow, what you see in front of you here, this workflow has gone through a broad evolution over the last number of months, to the point where today we can actually create from scratch a tenant environment in the course of about 15 minutes or so. Next slide, please. On this slide, you'll see in front of you, and the goal here isn't to give you an indication of all the code that's been written. It's more so to give you a feel for the fact that the GitOps code provides a platform upon which we can parameterize all of the necessary capabilities that customers are going to require to run their business, their applications effectively. And then when you see on the left-hand side, you'll note that there's a lot of additional platform capabilities, and I'll talk about this a little bit more on the next set of slides. But we actually have now built from scratch all of the component parts that are going to be necessary to provide the entire service solution to the customer. It's all completely parameterized, such that we've got a pretty consistent rinse and repeat model as we begin to onboard customers, or as customers need to evolve as they mature their business. Next slide, if you will, Paul, please. So let's look at it in a little more detail. At the very top, we have a trigger that occurs for the GitOps process itself. Typically, it's the fact that we've spent some time with the customer, more often than not have gone through an assessment with the customer to understand what are their applications, what's the scale of requirement that they have, how big is the tenant environment, how much storage, how much disk, all the typical things you would expect from a cloud provider point of view. So that data that we have, typically, again, coming out of an assessment, is used to create the parameters that I mentioned a little bit earlier, and that in turn triggers the GitOps process. What begins to occur is we deploy the TKG, we deploy Tanzu Mission Control. You'll see the TO reference there. It's Tanzu Observability. It used to be called Tanzu Observability. And we also deploy Carbon Black as a security component, container security. So we've got the entire overlay, containers or clusters as a service, another way of looking at it. That infrastructure itself is built in turn on a VMware Cloud profile. If you note down below, we create tenant is a multi-tenant, is the multi-tenant model that we're looking to put in place. This is all in turn built on AWS infrastructure. It's AWS i4i nodes. If you're not familiar with those, they're very large and very beefy boxes. Today, we started with a fairly robust cluster, and our ability to scale three-dimensionally when you look at this stack is going to be an important part of our long-term strategy. So first of all, at the physical layer, based on threshold criteria, we actually have the ability to add a net new node into the equation here so that we can expand the physical footprint of the overall tenant environment as is required. That would include processor, memory, and disk. This in turn is going to allow us to just add more tenants or rebalance workloads for those tenants. As you begin to move up stack, we now have an ability to auto scale or scale at the Kubernetes cluster level, so we can add additional clusters on the tenant's behalf. And then where necessary, we obviously have the ability to scale by number of pods as well. So the trigger strategy here is a GitOps approach to create the tenant. It's built on a very large footprint in an AWS data center. It's a VMware Cloud. It's got all the robustness that you would expect from VMware at the infrastructure level. And that creates the foundation of the core stack that we start with. Next slide, Paul, please. From there, we have the ability to overlay or have overlaid an entire DevOps pipeline. This is a combination of TAP, Tanzu Application Platform, as well as GitLab from an end-to-end DevOps experience. So imagine now what we have is working with the customer, a pipeline or a CI/CD set of triggers that allows to go through the typical DevOps progression from application development all the way through test and staging, and ultimately to a point of deployment. If you note the boxes that say app and OS, imagine in your mind those are containers or containerized applications that are running within the tenant environment. So the CI/CD trigger allows us to deploy applications themselves. That application environment runs in the Tanzu Kubernetes cluster. And ultimately, as you work your way down in the previous picture, it gives you the full scale of what's available from an AWS and a VMware cloud point of view. Next slide, Paul, please. This is another way of looking at exactly the same picture. I simply tried to draw it three-dimensionally. So imagine now we have those very large I4I nodes of VMware Cloud that's layered over the top of that. Upon an engagement with the customer, and again, that assessment that gives us an insight as to everything that's required, memory, disk, number of clusters, number of apps that would be deployed, et cetera. We create the tenant, and within that, we've overlaid all of the Tanzu portfolio, all the security pieces, as well as a number of other areas that Ken Ryder is going to talk about here in just a few minutes. And then we use the overall pipeline as a mechanism to facilitate the deployment of those applications. A couple of interesting areas that are also going to be talked about here. And we live in a world where AI is absolutely top of mind for so many customers. So first of all, you'll see, I think Ken's going to be able to point out an example of AI operations and how VMware and Tanzu Hub Insights, it begins to lay a foundation for AI ops to better and more intelligently manage the infrastructure with us and for us, as well as allow us to provide the highest level of availability that's necessary for the customer. That does trigger a second piece of the equation, which is for so many customers, they're starting to look at how am I going to implement, no, I'm sorry, can you go back one slide, please? There you go. The second thing that we're starting to see customers doing as well is they're looking very closely at how are they going to implement artificial intelligence within their own organization. For those of you who are pretty well versed in this, you'll know that a lot of the large language models are using publicly available content. The challenge with that is the fact that if a customer takes their information, their data, the knowledge that they have about their customers, and they make that information available to the public, clearly it feeds those large language public models, but they've lost their own intellectual property in that process. Accordingly, VMware has also announced a private AI initiative, and our infrastructure in these tenant footprints would allow us to support private AI capabilities, would allow us to access or leverage algorithms that are available in AWS Cloud Native and with VMware to facilitate their AI or customer AI development as well. So we are looking at this as a long-term strategy, not only for the entire modernization approach, but ultimately to help facilitate artificial intelligence evolution. Next slide, please. The last thing that I'd like to talk about is the fact that we are looking to leverage on the left-hand side some key component parts. The first is VMware has announced vSAN Plus. For those of you who might not be familiar with it, it's the typical storage area networking capabilities with a lot of scale and enhancements that are now baked into that, number one. So we do envision as customers have large data requirements, they're going to want to take advantage of the vSAN storage capabilities that are going to be baked right into the platform here. Secondarily, we have found that platform as a service or database as a service offerings, PaaS offerings, tend to be the most expensive investment in the cloud journey. And yet our ability, we believe, to provide full-scale capabilities and resiliency for database support, leveraging an underlying robust vSAN storage environment, we think is going to help drive cost efficiency for the customer. To the right-hand side, you'll notice a multi-cloud environment that we also have spoken with customers about pretty extensively. Baked into the overall solution also is VMware's service mesh that is available to us and NSX plus networking. Imagine what we now have the ability to do is to provide an overlay network over the internet and into the customer prem or into an AWS software-defined data center, or frankly, into a Microsoft Azure data center. And that one cloud overlay provides ubiquitous multi-cloud capabilities so that customers over the course of a period of time will be able to leverage Service Mesh as a way to move their applications from one cloud environment to the next. So there's a lot of activity, a lot of investment that we've made. We do have a vision for today at scale. We've built the platform. Ken's going to demonstrate what that looks like. We take full advantage of all the VMware robust stack of software that's available. We do have a vision of addressing database performance and data management at scale, equally important, multi-cloud and application movement, where containers are leveraging a service mesh to move those workloads around. So it's a fairly robust architecture that we have in place. So with that, I'm going to turn it over to Ken and give Ken the opportunity to actually show you some dashboards, give you a feel for what the stack looks like itself in practice. And we're excited about what the investment we've made and the opportunity to engage with you in your app modernization journey. So Ken, I'll turn it over to you.
Okay, thanks, Glenn. I am going to share my screen here, and we'll start taking a look at what we have built and what goes into it. So let me just share there. Hopefully you're seeing my screen now. And so what we're going to talk about is what actually we built and why we're doing it and what advantages it might have for you. So when we create a tenant, we're creating what we have down here on the bottom. You know, we create a tier 1 gateway for each tenant. Within that, we create network segments to house the various aspects of the solution. We're using NSX Advanced Load Balancer for providing that load balancing within the solution. So we have service engines which are attached to those segments in order to be able to route traffic to them. We have segments dedicated to the Kubernetes API VIPs and to any ingress VIPs that we have to create for the clusters. And then we actually have the cluster workload nodes, which are really vSphere VMs. So it's a pretty simple diagram, but there's a lot that goes into that. I mean, we have to use NSX to create those segments and those tier 1 gateways and the firewall rules that allow traffic to go between the various segments that have to go between them. We use vSphere to create VMs. We use NSX ALB to create the VIPs. And so we do that all through Terraform, as Glenn noted earlier. And we actually use Terraform to create all of those components in each of the various products that we're using. So in this example, for example, we're creating a network gateway policy. We're creating firewall rules that are associated with that tenant and so on. We use this to create the tier 1 gateways themselves. We use this to create the segments and so on. So all of that is done in code. So we're using Terraform to implement all of that. And what results is we end up in our VMware cloud environment, we're looking at, in this case, we're going to look at NSX, but we go off and create a tier for each customer. For example, we're creating a tier 1 gateway. And within that tier 1 gateway, we create network segments for them. So in this account, I'm going to use OHD in all of my examples here, but so we go off and create 4 network segments for them. And then we go and create firewall rules. And so this is, where go down here, but we allow, what sources, destinations, services, and so on that we're allowing, such that we are only allowing what's necessary to happen within that tier 1 gateway, but also into the outside world. And just to be clear, the only thing that's available in the outside world right now is an ingress to an application in one of those clusters. So we go off, we use NSX to do all of that. Within vSphere, we create resource pools that are assigned for the clusters and for the service engines. Each tenant has its own resource pool, so we can configure how many resources each tenant can use. And then, as I mentioned earlier, of course I got logged out. Log back in here. We use it to go off and create service engine groups, such that each tenant has its own service engine group for all of its load balancing traffic that we have in there. So as part of that tenant setup, we are creating all of that diagram I just showed. All of that happens using Terraform. Once that is done, we then use Tanzu Kubernetes Grid to actually go out and create a cluster. So we have up above, we have all of our management infrastructure. And one of the things in there is a management cluster that is responsible for managing all of the workload clusters in all of the tenants. So we use Tanzu Kubernetes Grid to create a cluster. That cluster itself, we set those all up to be auto scaling, so that if a particular tenant's cluster needs more resources, it can scale up by adding more nodes. And if it needs to then scale back, it can. It's similarly to what we do with VMC itself. The number of hosts we have in our vSphere cluster can grow as well based on the overall usage. So those are two levels of scaling that we've added in there. Once we create a cluster, it gets one of the things we install in there is Contour for ingress controller. That creates a VIP. As a result, we also create a public IP address for that. That public IP address, we then have a NAT rule that allows it to get into this ingress controller. And we also restrict the traffic there to only HTTPS by default. So that when at the end of this, we'll actually deploy an application to it, and it'll be available on the internet at a domain name and so on. So that all happens again as part of the creating a cluster. When we create a cluster, we then use Flux, and we take a GitOps approach to all of this, and we're using Flux, and I'm going to scroll back up here to install a curated list of platform services that we tend to use, and really from experience, things that every customer is going to need. And so on that list, as Glenn mentioned earlier, we have Carbon Black, and we'll get into that a little bit more. But we've added in things like Cert Manager to actually go out and manage certificates for you within the cluster. By default, we use Let's Encrypt as our CA, but if a customer has their own CA or wants to use a different public CA, they can. We can then go in and change the provider that we're using for those certificates. But by default, we use Let's Encrypt. Same thing on the external DNS. Because we're running on VMC on AWS, we use Route 53 as the DNS provider. But again, if a customer has their own DNS provider, external DNS supports a wide variety of DNS providers. So we can change that to a customer specific one. But again, if they don't need that or want that, we can do it for them through Route 53. We also install external secrets, and you'll see actually both external secrets and sealed secrets here. We're in the transition from sealed secrets to using external secrets exclusively. But we use external secrets by default. It's talking to AWS's secrets manager. But again, because it's very flexible in its configuration, we can use things like HashiCorp Vault as that secrets provider. We'll talk a little bit more about logging. We use actually FluentBit right now to do that log aggregation and send it to Tanzu Observability. And then we also have a couple other services that are really in there for our use. KubeCost, we use that to manage or determine the costs of the resources that are being utilized within each cluster. We roll that up to make sure that we're managing resources effectively. In particular, we look at things like resource requests and limits, and we'll talk a little bit more about that later. But looking at making sure that those are set right, such that you don't request too many resources, but you also don't limit yourself. So do a lot of FinOps there to make sure that you're getting the most out of your applications. KubeWatch, we use KubeWatch to send events from Kubernetes. As if you've been around Kubernetes long enough, the events in the cluster are only kept for a short period of time by default. And if you miss it, they're gone. We use KubeWatch to send those events out to our Slack channels, such that we don't miss any events that may be happening, warnings, errors, and so on that might happen in our cluster, so that we know what's all going on and keep track of those. So all of those are done. We bootstrap the system using Flux, and then all of this gets automatically installed into that cluster. And if I go out here, and I'm just connected to one of our clusters, you can see that we've used Helm to deploy all those applications. They all get set up out there, and configured to the same way for every single tenant, and every single tenant cluster. And as I said, over time, if the customer has different requirements, we can change those as needed. One of the things I didn't mention in here is that one of the other things we do is we actually integrate, or I should say more accurately, federate this with Azure AD, such that anybody who has kube control access to our cluster, they have to log in with their credentials, and we can define rules as to what they can or can't do. But having said that, overall, we try to limit the actual physical access, logical access to the cluster. So we try not to use kube control at all, but instead use some of the other products we have, and in general use GitOps for everything. So as the next part of configuring a cluster, we go off and I'm going to bring it up here. So we then add in integrations into Tanzu Mission Control and Tanzu Observability in particular, and Carbon Black. So within Tanzu Mission Control, every tenant gets their own cluster group. Within that cluster group, we organize their clusters within it. Those clusters, we can then keep an eye on what's going on in those clusters, what's installed on those clusters, if everything's healthy or not. Gives us a good sort of overview of what's happening in the cluster. But Tanzu Mission Control, TMC, adds a lot of other capabilities. In particular, I mentioned earlier, we can actually define access policies. So by default, out of the box, there aren't any access policies defined other than the default ones. So we've actually, for every cluster group that we create, we can actually go off and define specific access policies for those clusters. But in general, they're inheriting our policies so that we can get into those clusters and use our credentials to access those clusters. On top of that, we've actually provided a set of default policies that we install into every cluster. So by default, we set up, let me go, I'm an access policy assignments here. So by default, we actually go out for every cluster group, we create a baseline security policy. And I'm just going to pull this up here. But that policy, it has a defined set of things that containers can and can't do within that system. We've actually, in here, we've excluded some of the network system, or some of the system namespaces from that, those policies, because some of them do have legitimate reasons for, say, running as root or escalating privileges and so on. But by default, we set up these set of rules. It's a good general baseline. There's actually, we could get more strict than we have here, but by default, we keep it sort of middle of the road. But we also set it up to be what's called dry run mode. So it won't actually prevent anything from running, but it'll tell you that there's something wrong, so you can go off and fix it. Over time, we'd start out always these policies in dry run mode so that we don't break anything right out of the box. But once we have seen what the happens because of those rules, and we've addressed them, we will actually then go off and change them to being in a deny mode, so that if something tries to run that violates that policy, it won't allow it. So we actually create a default security policy for everyone. We also create some custom resource or custom policies, excuse me, that we define. So one of those is the allowed registries. By default, we only allow container images to be pulled from our, in this case, our GitLab container registry. So down in here, someplace right here, we're only allowing things from registry.gitlab.com. We can, again, over time, this would be changed to being a customer specific registry. They may have needs to use, Docker Hub, for example. I mean, we can change those policies, but again, we set a default policy that they can then expand upon. A couple of other policies that we set up by default are that we actually require liveness and readiness probes. So every pod that gets created out there, we require them to have a liveness and a readiness probe. Again, you can, over time, if somebody needs to, they can go change these policies as to, what types of policies or probes they're going to use. What ones they may add a startup probe as being a required one, for example. They may choose to exclude certain namespaces from it and so on. But by default, we're giving them a rule that we believe is a good rule to have out there, that everything that has every pod that's created has a liveness and readiness probe. Same thing for resource requests and limits. So in this case, we're setting it up such that every pod that gets created has to have requests and limits, and they have to, for CPU and for memory. So again, it's one of those best practices that we're trying to enforce on these. Again, none of them will prevent anything from working, but they'll tell you if they're not. We do have another one that we've actually added to the list. VMware gives you a defined a set of sample templates that you can use. We've added another one that we believe is a good one to have, which is requiring labels on your resources that you create. But there's no real good default for that. So we create the template, and then we would ask our customers to use things like what organization and so on each of these resources is for. And so over time, we would also want to enable that one. But again, all of this happens in our GitOps approach. When we create that TMC integration, we also create all of these policies out there. And then if we look at it, we can go out and look and for example, I'm looking at this OHD cluster. It's violating a few of these policies, and we have what's this ARIA telegraph collector. It doesn't have a liveness or readiness probe, and so we could go off and fix that, and so on. But this gives us, again, it's a violation, but it's not going to prevent it from happening. So we do all of that as a good set of best practices, we believe, for these clusters. In addition, for every cluster out there, we actually integrated, and I'm going to go here, data protection. We also integrated into data protection, such that these clusters are being backed up by default. It's on a daily basis, at midnight or something like that, GMT. And so we could create a backup of these ones just in case we need to restore. Although, given the fact that it only takes us a few minutes to recreate a cluster, restoring a cluster tends to not be a lot of times the best practice, but it's there in case we need it. Or if we want to clone this cluster for some test case or something along those lines. And then the last thing that we integrate as part of TMC was integrated with Tanzu observability. And I'm just going to go to Tanzu observability so that every cluster is actually producing metrics and logs that are getting sent to VMware ARIA operations for applications. But we get things like CPU usage, memory usage, pods are being restarted, and so on. We get a good view of any of the metrics that are coming out of our system. These are all the default metrics. If a customer has a container image that's producing more metrics, we can actually scrape those as well and just display them here. But part of this is that we also get, and I'm going to scroll up to the top, I'm going to go to alerts. And so we have a defined set of alerts that we've created And those alerts, in fact, we have one that says that a CPU usage is too high right now, and that's relative to what its limits at. And so we would actually be able to go off and look at these ones, and those are actually sent off to our Slack channel again. And I'm just going to pull that up here, but so we get these notifications of any new alerts that happen live on Slack. They also go into Jira, and then we also right now we actually send them off into RE Insights, which is going to be Tanzu Insights, but we send it off to there as well. And I'll talk about that briefly here in a minute. And then the last thing we mentioned, we integrate with Carbon Black. So we're doing runtime. This is real-time runtime security. And for example, you can see that it is keeping track of who's talking to what, whether it's talking out to the internet or it's talking to some other private IP address. We can see what's happening within that cluster. We can create rules based on that network traffic. And so I'm just going to actually go up here, and by default, every cluster gets an egress risk policy. And that policy, and I'm just going to, so you can see what it is, it actually will warn us if something in our cluster is going out to a high risk site or a malicious site that we know about. It's actually by default going to notify us when that happens. The other thing that we get out of it is, and let me go back here to container images. Yeah. And we can actually look at what's running in our cluster, and we can look at the vulnerabilities and the images that we're running. Ideally, as part of the SDLC, we'll actually be scanning for vulnerabilities, but over time, new vulnerabilities are found, and things that are already running may know about a vulnerability. So we also have that in there, to alert us if something is running. In fact, we have 24 images running across all of our clusters right now that have critical vulnerabilities in it, and we're probably off addressing what those are and why, and do we need to be worried about them right now. The last one, and I'm running out of time here, but we've actually Tanzu Insights is now in beta, and we've actually integrated this with it. So we actually have Kubernetes events are coming in here. The alerts from Tanzu Observability are coming in here, and it is going off and correlating those events and making suggestions based upon what it sees. It's making sure if two events happen, if they're correlated, it's going to bring them together into one thing, and then we can go off and then use that to go off and address what may be happening in those clusters. So that was a quick view of what we have done by default, and I'm going to turn it back to Paul.
Hey, Ken, thank you. That was very thorough, as you always do. And as you were talking, I had the question about security, but I think exactly what you said around Carbon Black helped to address it. So, Karen, I know you were going to hop in and help us with a few questions as we're right at the top of the hour. Go ahead.
Sure, thanks. And I was going to say the same thing. Thank you so much for this amazing solution you've created. And there's a lot of work behind it that you've essentially taken off the hands of the users at our clients who are probably struggling with all that kind of work. So thank you. Real quick, we did have a couple questions around tenancy. I do know the answer to this one, as in, does each tenant get their own dedicated cluster, or do they share clusters, and how is the security and firewall handled? I can pass that over to Glenn and Ken to answer. And then also a question on Terraform, but I know we're pretty close to the end here. So Glenn and Ken, go ahead on those two questions.
So on the tenancy one, every tenant, well, and actually we have the option. We could create a different VMC SDDC for a tenant if that's required. But by default, they all share the same SDDC vSphere cluster. But as I showed, we have a tier 1 gateway for each tenant, and within that, they have their own cluster. So they're not sharing Kubernetes clusters.
Yeah, I think the real key takeaway here is the fact that the multi-tenancy piece is built on a VMware cloud. It was the picture that I showed a little bit earlier. So foundationally, the big nodes and the typical infrastructure is a shared infrastructure that's driven to facilitate economic efficiency for the customer as much as anybody else, as well as us, I should say. But at the same time, each tenant is a secure environment. There's the ingress and egress in and out of that tenant. Everything that resides within that tenant, as Ken has taken us through, is that customer's environment. It's their configuration, it's their clusters, it's their services and their apps. So there is no ability to touch cross tenancy or anything along those lines. So we've eliminated that as an exposure. So the customer has their environment. That's what, in a sense, they use. That's their consumption.
Thank you. And then a question on HashiCorp moving to OpenTofu and your Terraform. Do you have plans or roadmap plans for your use of Terraform today?
I don't think that, at least from my reading, I don't believe that the change in licensing to Terraform is really going to impact us. We're not, I'm going to say, selling Terraform, we're selling our service. And so I don't think it'll impact us. I mean, obviously, if our lawyers think otherwise, then we'd probably go to the open model, but I don't see it impacting us right now.
Yeah, the key takeaway there, Karen, is exactly what Ken said. This is our environment. It's our code. There has been a tremendous investment for the good of the group. There's been a tremendous investment made to make all of this completely programmable and fully automated, such that the customer's experience is as high a performant and reliable environment as we possibly can. One other point I do want to commit is the fact that there are service level commits that we have associated with this entire solution. So when a customer signs an agreement with us, they do have service level numbers that we are committing to those customers. And it's for that reason that we've made such an investment in GitOps. Programmatic capability is going to be key to enforcing reliability.
That's great. Thank you.
Great. And Karen, I think that's everything question wise.
Yes.
Yeah. So again, thank you. I know we're right at time. Thanks for everybody joining today. Just a couple of comments. So again, on behalf of VMware and Capstone, we really appreciate your time. The couple of sales leaders, Ashley Smith and Matt Bentley on the engineering side at VMware, feel free to reach out directly to them. If you're on the East Coast, you may already know who they are. Also, Kirky's email address is on the screen in front of you. The email domain to reach the folks that you've talked to or heard from today, Glenn and myself and Ken, if you'll send a note to solutionsales@capstonec, C as in consulting.com, plural on solutions, plural on sales. That hits all of us, and so we'll be able to respond to you there. Again, any feedback you've got for us for today, thank you so much. We really appreciate you joining, and hope to connect with you live to talk about your application modernization journey. Thanks all.
Team. Thanks much.